essentially the problem of finding the tangent line at point P boils down to the problem of finding the slope of the tangent line at point P. Okay, so finding the tangent line, the first thing we need to do is find the slope. It says you can approximate the slope of the tangent line using a secant line through the point of tangency of a second point of a curve. Okay, that's a lot to swallow, and I'm not going to lie, if I wasn't a math person, I probably would have no damn clue what they just said. So let's remind ourselves, let's go back to the basics here. Do you remember slope? Slope is usually done by m. It's usually the y2 minus the y1 over the x2 minus the x1. You guys with me? And so if I had something like x squared, here's the graph of x squared, and I wanted to find, well, let's think about some points on x squared. How about the point 0, 0 and the point 2, 4? If I wanted to find the slope of the line that goes through that point, the slope of the line that goes through that point, I would do the first y value, which is, the second y value, which is 4, minus the first y value, which is 0, the second x value, which is 2, and the first x value, which is 0. And I want you to be careful. It doesn't matter which point you say is the first or the second, but it does matter that the corresponding x and y's are on top of each other. So if you notice, 4 is above 2 and 0 is above 0. So that's what's important. The order doesn't matter in which one it is. Okay, so if we continue, we would have 4 over 2, which is simplified to 2. So the slope of the line between the point 0, 0 and 2, 4 has a slope of 2. You can remember this as rise over run. You can remember this as go up 2 and right 1. But that's what the slope is, okay? What is the slope of that line called? Technically, that is called the slope of the secant line. The line that goes through those 2 points is called the secant line, okay? So what are we going to be doing? We're going to be looking for finding the equation of a secant line. And then we're going to take these 2 points, and we're going to move the second point closer and closer and closer to the first point, and that'll be the slope of the tangent line when this point gets infinitely close to it. But let's step back. Let's make sure you're comfortable with secant lines. Again, I've shown you a graph here. We've got the first point, x1, y1, x2, y2. How do we find the equation of a secant line? Hopefully you remember this, because finding an equation of a line is something that we're going to do numerous times this semester. It says to find the equation of a secant line, first thing you need to do is find the slope. First thing you want to do is find the slope. Second thing you're going to do is you're going to plug it into point slope form, which is y minus y1 equals m times x minus x1. Yes, you need that memorized. And then the third thing you're going to do is put the answer into slope-intercept form, which is y equals mx plus b. So let's see an example of going through those 3 steps right there. I'll start off with step 1. Step 1 is to find the slope. To find the slope, we would have, what we have to do, if you want to look at it, this is x1, y1, this is x2, y2. And let's go ahead and write the formula. It's y2 minus y1 over x2 minus x1. So you can just plug them in. The second x value was negative 2, minus the first x value was 4. The second x value was 2, and the first x value was negative 2. Notice anytime I subtract negative, I did it with the positive, that wasn't necessary, but absolutely necessary. Anytime you subtract a negative, make sure you put parentheses there so you distribute the negative properly, okay? Again, what I want you to notice is that it doesn't matter which order you chose as the first point or the second point, but notice the negative 2 is above the 2, and the 4 is above the negative 2. So it's really important that you have those lined up properly. Okay. So let's hit equals here. Negative 2 minus 4 is a negative 6. And then 2 minus a negative 2 would be a positive 4. This would simplify to negative 3/2. So that gives us our slope. So now what do? We go on to step 2. And when we go on to step 2 here, we want to put it into the slope-intercept form. What's the slope-intercept form? Well, that's y minus y1 equals m times x minus x1, right? Okay, so in this case it would be y minus, well, we could choose either point. Doesn't matter if we use negative 2, 4 or the point 2, negative 2. I'll just use the first one, which is negative 2, 4. So my y value is 4. I put my slope, which is negative 3 times, and then in parentheses I do x minus the x value, was x minus negative 2. When you subtract a negative 2, that turns into plus 2. Now what do I need to do? I need to do some math and solve for y. This is the third step. So I'm going to multiply negative 3 times both of those terms. I'm going to do it over here so I have a little bit more room. So I'd have y minus 4 equals, and then as I distribute that negative 3 through, negative 3 times x is negative 3x, and negative 3 times 2 would be a negative 6. Last thing I need to do is add 4 to both sides. When I add 4 to both sides, I end up with the final answer of y equals negative 3x. Negative 6 plus 4 would be a negative 2. So that would be my final answer there. Y equals negative 3x minus 2. We have now found the equation of the line through those 2 points. There it is, if that was the secant line. We have found the equation of the line through those 2 points, okay? So it says the tangent line to a graph at a point pxy is the line that best approximates the slope of the graph at that point. So that's important for you to understand. The tangent line is the line that best approximates the slope of a graph at a single point. So imagine now if I said, I want you to find the slope of a graph at a single point. Well, think about it. What do you need to find the slope of a graph? To find the slope of a graph, you need 2 points. You need y2 minus y1 over x2 minus x1. How could you find the slope of a graph at a single point? I mean, if you did y2 minus y2, x2 minus x2, or same thing with the ones, you'd have 0 over 0, which is undefined. So how can we find the slope of a graph at a single point? We know how to find the slope of a graph between 2 points. How do we find a slope of a graph at a single point? And that's the concept of finding the equation of a tangent line. Sorry, finding the slope of a tangent line.